Welcome at our session at the edge is here and how the edge will improve large-scale digitalization initiatives. Let me welcome you, and we're very happy to be at the HMI today as well. I'm Eva Schönleitner. I'm the CEO of Crate.io. Crate.io is a database technology specifically made for machine data and digitalization initiatives. And Bernhard, why don't you introduce yourself?
Thanks. Yeah. Hello, everyone. My name is Bernhard Zimmermann. I'm the responsible director of business development for Zülke here in Austria. And we're a system integrator, and we're happy to have you here in this session.
Wonderful. So why are we even talking about this here? We all know for several years now, many industrial companies have been working on pilot projects in terms of digitalization, but it truly now is here to stay, and it's coming very aggressively and even larger every year. The latest IDC numbers show that AI type revenues, which also includes machine learning, are already estimated to be over 300 billion this year, with a forecast up to over 500 billion in the next 3 years. So it really is here to stay. And now we're moving into a commercialization that then requires certain technologies to really mature to scale for these kinds of use cases. And that's what we're actually seeing. The technologies that we've been using are maturing very rapidly. We have the hyperscalers, we have new connectivity solutions, including 5G, machine learning databases, self-servingly, my own company, AI tools, applications, several AI software platforms emerging, and to the point, for instance, Zülke, our partner, consulting firms that really specialize in supporting our customers in driving these digitalization initiatives. And we'll hear more about this in a bit here today. What are some of these learnings over the last several years that we've been capturing together? What we're seeing now is that to have a highly scalable data infrastructure is really key. To go from a pilot to something that goes into operation, into control loop environments, you absolutely have to start with the right foundation. You also need to know, have a clear data governance model, so that you're starting out on the right path. And we also learned that the idea of starting with pilots, moving these pilots into production, and then scaling out to multiple locations, plants, and so on, is still the right way to go, and is also the safe way to go in terms of impacting productions and production systems in a positive way, and being on the very safe and secure side that industrial companies expect and have to do going forward. The one learning that we've all had here is that in the past, as you know, we've started with on-prem solutions, then everybody moved to the cloud. Most of these pilots have been all cloud based, but in order to scale and really implement the large-scale digitalization initiatives, we found that you really need to deploy a complete combination of edge and cloud. And so Bernhard is going to explain a bit of how this actually works with some customers and how actually the structure of something like this looks.
Yes, thank you, Eva. Let's see how a scalable digital ecosystem, how we call it, looks like. It's a scalable data platform. Normally, you have your machines in your company, and you also have your traditional IT systems, which support, for example, enterprise resource planning or CRM systems. And they are driving your business processes. It means logistic processes, maintenance processes, and so on. And to have a complete digital ecosystem, you want to serve your end customer. So your end customer is typically requesting data from your company. So he wants to know where his project, in which production state is his product, or when this product will arrive at his site. So to realize this request from your customer, you need to collect the data from the operation technology and also from the IT systems. In the IT systems area, it's more or less standardized. So every big ERP, CRM, PLM system has their well-defined APIs. So getting out data from this system isn't such a big problem normally. But on the other side, the machines, this is a big topic because you have all kind of controlling units, different manufacturers and so on. And there is no real standardized protocol. Newer machines support protocols like OPC-UA or MQTT, but in the broader view, if you look in your production line, you have systems which are older than 5 years, and then you have to connect directly to these heterogeneous control units. And this is where the gateway technology comes in. So you need a kind of protocol translator to get the data out of the machines directly from the control unit and then play it together with the IT data into the cloud-based system. This is normally the case. And within this cloud-based system, we use the Crate.io database because this is a database who can scale very well. Because as you know, IoT data could be less, but it could be a massive amount of data because we have sometimes sensoric, which they are producing 15,000 data points at a second. So a lot of data normally is needed for special production processes, and you have to store this data somewhere, and you need a real massive scaling database to do this with IoT data in combination with your IT data. And Crate.io is the best platform for doing this. And based on this database platform, we are using different analytics and machine learning tools to understand your business processes or your production processes very well and to get insight into this. And also with this data, we are using this data for user applications. So as I said in the beginning, your user wants to know more about his product, in which production state is it, or when will it arrive. And then we have user applications like your customer portal, or if you have an app on a smartphone, which you want to give to your customer, then he can have a deeper look into the actual state of the product. But this is not the only use case you have. You also have, for example, R&D, your research and development department. They also want to have access to this data because now it's there. You have your data platform based on the Crate database, and you have access with different APIs. It depends on which analytics tools or research tools you're using. And this is the typical use case for the R&D department. The service department also wants to have access to your machine data. For example, if you have your service technician on the shop floor, he maybe has an HoloLens for augmenting data on the shop floor. Then you have your access to the database with the HoloLens through this digital ecosystem, and you can display the actual state of the machine where you stand in front of. And also you can have a virtual control display where you can tweak your parameters on the machine to optimize the production line. So these are the normal use cases we are addressing with the traditional ecosystem, let's call it so, but we see that there are limits. As Eva told today, a lot of use cases in the IoT sector are cloud only based, but there are some use cases which need also computing power, let's call it so, on the edge, directly on the shop floor. For example, if you want to have near real-time communication, because you have analytics in place, you can tune your parameters, your algorithms, but the algorithms also want to take control of some parameters directly on the machine, on the control unit. So you need real-time communication, and this can be solved with edge computing technologies. So you have an edge computing device at the shop floor, which is directly connected to the cloud, and where you can have such scenarios. But let's go into more detail about this edge computing technology. Normally, we also have the Crate.io database also on the edge computing device and in the cloud. And this is the beauty of Crate.io because it supports both scenarios and it could be managed in both ways through the same layer. Eva will tell you about the edge technology a little bit later. So we're using the same database technology and even the same analytics tools in the cloud and on the edge device. So we have now analytics possibilities on the edge device itself, and we can in near real time also take over control units or tune control units through this edge technology. A big use case for edge technology is computer vision, because as you all know, computer vision is a big topic in the quality assurance sector, but this is a lot of data, a massive amount of data which you have to analyze, and this is normally done directly on the edge to also have influence in the production process. And secondly, we can also run user applications directly on the edge. And the beauty of this solution is that you can use the same software code which you're using in the cloud on the edge device, fully managed by the cloud if you want to. So if you have your dashboard directly on the production line, you can have the data directly from the edge device. But, and this is the beauty, you can measure it against other subsidiaries or other production lines in other countries through the cloud-based system. So there is interconnection, for example, for benchmarking your production line with other production lines. And the beauty of this complete edge technology is that you can have one control environment, which is more or less the cloud-based environment, where you also control your edge devices. And you use the same components there. So it gives a lot of new use cases which you can use through this splitted technology. But let's have a look what we have done for customers with this digital platform topic. We implemented more than 10 years ago the fleet management system at Liebherr, where we also developed the gateway technology, the device which is retrofitted on the construction machines, and we set up the complete backend and frontend for Liebherr. At Herrenknecht, we did the same with data platforms. So they now have data from their tunnel boring equipment, because the uptime of this tunnel boring equipment is essentially critical for their business. And they now have the data platform in place to optimize the uptime from this equipment. At ThyssenKrupp, we digitalized the complete sales process. So in this case, we're using HoloLens to measure the staircase at a customer. And this measurement data is directly transferred through the digital ecosystem to the production line. So there is no need, there's no need to split between those two cases from getting the data, transferring it to the production. It's completely automated through this digital ecosystem. And the fourth use case I want to go into detail is the smart connected production, because this is interesting for you guys, I think. There we connected new and old machines. I told you the new machines normally is not a big topic because you have MQTT or PCUA in place, but the old ones are the tricky ones, because sometimes you have to connect to very old control units, which is normally possible. But in really old machines, we also have to bring out additional sensoric, for example, which we can do at Zülke. This customer had also multiple locations and over 1,000 heterogeneous machines which we have to connect to the digital ecosystem platform. What we did in this project, we defined the project scope and the roadmap, and we also developed the concept for increasing the overall equipment efficiency for several production sites. And then we did the prototypical implementation. And this is the beauty in combination with Crate, because we can start small for the first prototype use case, but we don't have to throw away all these topics. We can keep these topics, and we can scale up as we want with this platform. So there's no need to throw it away, the prototype. We can use this prototype and then make it bigger as you want to grow your use cases. And within this project, we managed to get more transparency in the production. So we get more insights how the production line is used and where we can optimize. And of course, the optimization of the OE is always the top #1 topic in this area. And the last point I want to mention is also that these digital ecosystems are not a closed platform. It's an open platform, because we know that customers typically have their own third-party tools in place they want to use. And our platform together with Crate.io has this openness to also have the connectivity to this tool or to this tool chain. So let's hand over to Eva back again.
Perfect. Well, thanks so much, Ben. I mean, this was perfect, and set it up really well of the use cases and why exactly, I mean, edge computing is really important. And so what I'd like to announce today actually is that at Crate.io, we are announcing the Crate database at the edge. And we, as I mentioned, we've always had it on the cloud. We also had it on-prem. We still have this, but really, really beneficial for large-scale IoT digitalization initiatives is it to have it both on the cloud, on the edge. And what does it mean on the edge? You described it actually perfectly. I should hire you, actually. I was thinking about that. But what does it do is you have a Crate instance in the cloud, and from there, you can also deploy clusters on the edge, meaning an edge is a location. So we did a few little pictures here. Think of a factory. It could be a ship. It could be a mine. It could be renewable energy, anything where there is a location and there is a database needed and there is compute on that database in a certain location. And you can have many of those. So, an example, we have a customer that has a large consumer packaged good customer, has 180 plants. We currently have a solution deployed at 16 plants, and now we're scaling out. And that is actually one of our lighthouse customers where we realized, wow, cloud alone will not cut this in terms of timeliness, being able to be independent of the internet if you have to. In some, let's say, sort of select countries, the internet is not as strong and not always up. If you're in a production environment, what do you do then? You have to do the compute on the edge. And also, some customers don't, for security reasons, want to have the compute on the edge. What's the difference between this edge and, let's say, it smells almost like on-prem, but it isn't, because the deployment happens to the cloud, the management happens to the cloud. That assumes, of course, there is a connectivity sooner or later, but it doesn't have to be there all the time. The data also, the learning models very often are done in the cloud, and we've seen this in the model before from Bernhard. But then the computation, the analysis, the adjustment of the control loop of, let's say, a factory happens on the edge. The learning model gets adapted. You can adapt the learning models on the edge as well. But if you then, that would be only one plant. If you have a learning model that goes across, let's say, 100 plants, and you want to have a consolidated one, eventually you want to bring it up to the cloud. So both on our edge product, we have one, the management, and secondly, also the select and sending of data up to the cloud. And you don't need to do all of them. You can only do select ones. And that's the beauty here, because if you have 1-2 use cases in a factory that already produce massive data, it's great, but a smart factory has many, many use cases. So if you think of the petabytes of data that you're basically producing every hour in each of these factories, and then want to send all this up to the cloud, you might not need all this data. Just think of what data does normally get collected. I mean, sensor data is the obvious one, or pictures, images of, let's say, visual recognition. Think of sensor data and you measure temperature. Well, the temperature is 21 degrees and it's constant, and it's still constant, and it's still constant. You really want to send this all up to the cloud? Maybe not. Maybe you want to send the outliers, you want to send the trends and things like that, and have the rest of the compute on the edge. So this is really what it is, our solution. What I'd like to, and of course our technical teams will explain way more than that. If you could go to the next page, please. What I'd like to do is, starting today, we actually have an early adopter program where you as customers can try this out and also start deploying. It's more than a pilot, like Bernhard said. You can immediately go into production as well and really truly scale it out. And what do you get in this early adopter program? A very deep interaction with our technical teams, our customer engineering teams, and even our feedback to our developers right back as we develop the next generations already of their both cloud and edge solutions. And then we team very closely with Zulke, especially if you're in the DACH area and the UK area, but also in other countries, to actually help you deploy and help you implement this combination of cloud and edge solution. So please join here, use this QR code or go to our website, and you will find the information of how to join this program. And we're very much looking forward to working with you on this edge solution. I see there is a question here. Let's see, which technology adopted at the edge level to manage connectivity, local applications, security, and so on? Maybe I read it properly because it might be something for Bernhard. I don't know. It's asked, which technology adopted at edge level to manage connectivity, local applications, and security, and so on?
Yeah, it's dependent on the customer use case. For example, what we did is we used Azure Cloud Technology for connectivity, and also using Azure Edge Technology because they have a complete software stack, which is open source, of course, which is always a topic at customer side, especially at industry customer side. So we're using depending on the cloud provider you're using, for example, Microsoft or AWS, then we use the technology to also manage the edge devices and also the framework behind it.
and that create one of our strongest partner is from a platform, a hyperscaler perspective, is Microsoft, as we see a lot of the IoT customers are using Azure. And then we also work natively on Amazon, and you will be seeing some more announcements coming shortly about the remaining ones. Let's see, there might be another question. Nope, it seems like we're good here. Bernhard, do you have any parting words here before we give it up?
I think everything is set. I think the edge technology really is a game changer for some use cases which you hadn't been able to address before. And I think the beautiness of this whole concept is the management behind it. So you don't have to develop, for example, device management for yourself. You can use the existing device management of cloud providers like Microsoft, and you can leverage this one. So you really can concentrate on your use cases, and the management is a topic which is already solved, which you can use. And this is also my message to you. Think about the use cases, because the use cases is driving this digital ecosystem, not the digital ecosystem for itself. So think about interesting use cases and then decide if you want to put this use case more on the edge part or more on the cloud part. It really depends on the use case. There is no one fits all, but the technology is there. You can use both platforms, let's call it so, but managed by one platform.
So Bernhard, there's one more slide actually. If you could just move it forward. There we go. So for everyone, we'll leave this up for a few minutes here so that you can both the QR codes, scan those in, but obviously our websites will also bring you right back there. And we appreciate your feedback. Please keep it coming. And otherwise, you will find us both on LinkedIn very easily. Please feel free to contact us. And as I said, we are really eager to get started with you. Thank you so much.
Thank you.